we're recording. So this is just a continuation of yesterday's lesson. We are solving for two equations with two unknowns by a method called substitution. This example is a little bit trickier than the last one because notice there's no single variable here that only has a coefficient of 1 on it. This one's got a 5, a -3, a 4, a -6. But you can substitute for any equivalence that you can find. So the first thing I notice about this, I'm going to write down, notice that 4, -6, and 18 are all divisible by 2. So that means that if I divide the entire equation by 2, I don't change the equation any. It's still the same line through space. So this is going to be 2x minus 3y equals 9. And you might be wondering, well, that didn't really solve your problem there, Mr. K. I mean, I still don't have any 1s for coefficients. But notice that this is the same term here and here. So I'm actually going to rearrange my equation so that it says -3y equals 9 minus 2x. Hopefully everybody understands what I just did there, right? I minus 2x from both sides of the equation.
Wouldn't that be incorrect?
No, that's exactly correct. This negative belongs to this 3. And to isolate this term, I minus 2x from both sides.
Yeah.
Now, I can substitute 9 minus 2x for -3y. So in this equation here, I'm going to take that first equation. For that equation there, I'm going to replace the -3y with 9 minus 2x. Now I left a blank here because I wanted us to think about it. Should that be a plus or a minus? It's a plus. Why do you think it's a plus?
Because when we substituted, we kept -2x, and then we didn't change anything but positive or negative.
Yeah, this is the way I would explain it. I am replacing this entire thing with that, which means I'm replacing its negative value as well. So this is a plus. Think of the logic of why that is. Okay, and now that's grade 9 algebra now. It's one equation with one unknown. 5x's minus 2x's is 3x's. Now it's grade 8 algebra. I minus 9 from both sides. I divide both sides by 3. And I've solved for x. Okay, I need the other solution now. I need to solve for y. So I go back to this equation here. And I substitute the x I just figured out, which was 3. And now I do some bed mass here. 9 minus 2 times 3 is 9 minus 6, which is 3. Then, careful with this one, I have to isolate y by dividing both sides by what? By -3. So on this side it becomes 1y, and this side it becomes -1. So that's what I think my solution is. So my solution is 3, -1. If I were to graph those two lines, they should meet there on the grid. But I did this algebraically. I don't have a picture to look at, so I want to check my answer. So I'm going to do a check. And remember how I do a check. I plug the x and y numbers in. Now, I kind of already used this equation a couple times, right? I rearranged it and divided it by 2. So I haven't done as much with the first one. That's the one I'm going to use for my check. 5 times the number I think x is, minus 3 times the number I think y is, has to be 18. Is that a true statement? If this isn't a true statement, I've got a wrong answer. I've done something incorrect. So 15 plus 3 is 18, and yep, that works just nicely. Check. Answer is correct. So there we go. So that's our substitution example 2 that we didn't get to yesterday. We've already done example 3. We're ready to try some on our own in our assignment.